Lesson 6.1 and 6.2. This unit you're going to get off easy because we're going to combine some of the videos together. So this is going to cover 6.1 and 6.2. We are going to do a lot in this. I would recommend cutting your notes into 4 sections because we're going to define scatter plot, we're going to identify a line of best fit, we will write that equation for the line of best fit, and we will use that line to make predictions. So we're going to do 4 things. So I would recommend stopping right now and dividing your paper into 4 sections. Alright, the first thing is defining a scatter plot. We have to know what a scatter plot is. And here's the definition. A scatter plot is simply, it's a graph of data points. That's it. The big thing to know here is that it's not necessarily going to graph a straight line. So far we've been doing linear functions, like y equals 3x plus 2. That's going to graph a straight line every time. A scatter plot is not necessarily going to graph a straight line when the plots are graphed. Because here, if you notice, here we have chirps per second, so this is about a bird, and then the temperature. So this graph is showing that, 3 chirps per second if the temperature is just over 2 degrees. Okay? So that's the relationship that we have going on here. Okay? This is not a straight line. It's a correlation, but it's not a straight line. This is a scatter plot. Okay? So go ahead and get that into your definitions. The next thing we need to do is determine the line of best fit. All that a line of best fit is we're going to take this scatter plot that does not form a straight line necessarily, and we're going to draw a line through here that would best fit the data. And essentially we want to try to split the data in half. Okay, so I've done one here. I'm going to draw a straight line, and if I do that, I can kind of tweak it, and right there, that splits the data about in half. I have 1, 2, 3, 4, 5 on that side, and I have 1, 2, 3, 4 on this side. So I'm about equally distributed. Okay, I have an odd number, so there's going to be more on one side than the other. Okay, but that's all a line of best fit is. It's simply splitting the data. Okay, where this data is going to kind of correlate around that line. Okay, so now we've taken something that is not linear. Okay, and we have put in a linear line of best fit. And if we have a linear function, then we can find its linear equation, okay, which is the next part of this. So now that we have this linear function, we want to find its equation. And that's what this is here. Writing the equation for the line of best fit. So the first thing that you need to remember is, what's the formula for writing an equation? What's that standard notation for writing any equation? We talked about it all in Unit 5. Y equals mx plus b. This is not going away. Okay? This is the core foundation of all things algebra. Okay? You've got to know y equals mx plus b. Please recall that b is the y-intercept and m is the slope. Okay? So for this, those are the 2 pieces of information that we're going to have to gather. I would always start with your y-intercept. Let me get a pen here. Okay? Alright, so look at this line. Where does the y-intercept happen? Where does this linear function hit the y-axis? The line that we drew. It hits it right here at 0. Now, that's not always going to happen. I picked this one because it's an easy example. So my y-intercept, or my b, is going to be equal to 0. I recommend you get the ordered pair. What's the ordered pair right here? It's 0, 0. Because in order to find m, how many ordered pairs do you have to have? You have to have 2 ordered pairs, which is the essential reason why I told you to write down the ordered pair for the y-intercept, because that's one of them. Now you only need how many more? You only need 1. Now we have to look for perfect intersections, okay? And right here happens to be 1. And what is this ordered pair right here? It's 1, 1. Okay? So how do you find slope? What's that formula? You had to memorize 2 formulas last unit. This one and the other one. y2 minus y1 over x2 minus x1. Okay, oops, that needs to be a 2. Okay, so I'm going to label these x and y. Here's 1 and here's 2. So who's y2? 1. 1 minus 0 over 1 minus 0. Well, you're going to get 1 over 1. So what's the slope of this line? M is equal to 1, because 1 divided by 1 is 1. Do I have M? Yes. Do I have B? Yes. We know that it's 0. Can I write the equation of this line? Yes, you can. Okay, so take a minute, pause, fill in what you already know. And here we go. I've written it all over here. The rise was 1. I had to rise 1. I had to run 1 to get to my next point. So the equation of my line of best fit is y equals 1x plus 0. Or write it like an algebra student and it would just be y equals x. Okay? Now, if I use this equation, am I going to get all of these little points? No, I'm going to get the points on this line. But that's why it's a line of best fit. Okay, because it best fits this data. If I plug in a value, I'm going to get somewhere close to here. So let's plug in 3. If I plug in 3 for x, okay, 1 times 3 is 3. So y should equal 3. Okay, well, I go over to x is 3 and y is 3. Well, that puts me on the line, but did that give me my point? No, but it's pretty close to it, okay? It's pretty close, and that's what you're looking for. It's a line of best fit. It's not perfect. It's the best fit. Next one. Now we have to be able to make predictions, okay? So we've been able to write the line of best fit. We came up with the equation, y equals 1x plus 0. Now we need to answer the questions, okay? So what temperature would it be if the bird chirped 20 times per second? Well, my graph doesn't go all the way out to 20. So instead of using my graph, what other part of the multiple representation could I use to figure it out? Which part would I want to use? The algebra part. So 20 times per second, is that going to go in for x or y? Good, it's going to go in for x. So we would have y equals 1 times 20 plus 0. And you do the math, that's pretty easy. 1 times 20 is 20. So if I wanted the bird to chirp 20 times per second, how many degrees would it have to be outside in Fahrenheit? It would have to be 20 degrees Fahrenheit. Okay? We're making a prediction. Our line doesn't go that far, but we're going to use our line of best fit to predict. Now, it's a line of best fit. Is it going to lie right on 20 degrees Fahrenheit? It might not. It might be a little bit above. It might be a little bit below. But that's why it's called a line of best fit. If it were 12 degrees outside, how many chirps would this bird chirp per second? So 12 degrees. Is this going to go in for x or y? It's going to go in for y. So I'm going to do it up here. 12 equals 1x plus 0. Okay, well, I minus 0 from both sides. That just gives me 1x is equal to 12, and isn't that what I wanted in the first place? So how many chirps per second would it be if it were 12 degrees outside? It would be 12. And we're making that prediction because if you notice, my y-axis doesn't go up to 12. Okay, I have to predict. And again, it might not be exactly 12 chirps. It might be 11.52. Okay, because this is a line of best fit. All right. I'll show you how to do this on the calculator later to get more exact examples. But for now, the big part is this slide right here, being able to write the equation. If you struggled in that in Unit 5, you need to go back and do this again. I can't make you, I'm not there with you. But you have to do that for yourself. This is the big concept, slope-intercept form. This is not going away. We have got to ingrain this into our little heads, okay? Y equals mx plus b. This one equation can take you so far. So please make sure that that is in your notes.